minus 2 into 5 squared. 5 squared is what? 25. 25 times 2, that is minus 50. Then this one is 35, then plus 15. 15 plus 30, 15 plus 35 rather, that is 50. 50 minus 50 is 0. That means x equals to what? 5. You can see the way I've been able to cross-check this now. 50 minus 50 is 0. So 50, x equals to 5. Then x minus 5 will definitely, x equals to 5 is a solution of this quadratic expression, while x minus 5 will definitely be a factor. So I will just go there and use to get the other factor. Okay, x minus 5 would now be what? A factor of it. Then since the question asks us to find the one that will be a factor, so it's x minus 5. So we go to the option and pick the one that correlates to that. So that's x minus 5. So C, option C is the answer. The next question asks us to factorize. The question asks us to factorize this. So in this situation, we are given ax squared, a square x rather, minus b square y minus b square x plus a square y. That's what we are given. So what we do here is to bring those that are similar together. Let's take this one to this region and bring this one to this region. Then I will have ax squared minus b square x plus a square y. This is not ax squared. This is a square y, a square x, b square x, a square y minus b square y. That's what I have. Then what is common to this? Let's dissect this way. So what is common to this? X is common. So I have x into a square minus b square. What is common to this? Y is common, plus y into a square minus b square. But what is now eventually common to this? A square minus b square is common to a square minus b square. So then a square minus b square is here. A square minus b square is here. So I'll just say a square minus b square. Then what would I be left with? X plus y. So am I going to leave my answer this way? You might not find the answer this way in the option. Really. So you can still break this down into, you know that this one is what? Difference of two squares. Then I can now break it down to a minus b, a plus b into x plus y. So this is my final answer. You don't see the answer this way, you definitely need it this way. Then the next question says that find the values of p and q such that x minus 1 and x minus 3 are factors of this. So this is also testing factors theorem. So if these ones are factors of this, automatically the f function of this must be equals to 0. So what are we going to do now? So since the function, let's say our function is f of x, and it is what? Px cubed plus qx squared plus 11x minus 6. So now, since we are told that x minus 1 is a factor, then x minus y equals to 0, then x equals to what? 1. So I can try f of 1. F of 1 will be p into 1 cube. Anywhere I see x, I will replace with 1. Cube into 1 square plus 11 into 1 minus 6. Everything will be equals to what? 0. Take note of that because it's a factor. So it will be p, because 1 times 1 times 1 is 1. 1 times p. 1 square is 1. 1 times this cube plus 11 minus 6. So at the end of the day, I will have p plus q. And this one is what? 11 minus 5. And 11 minus 6, that is plus 5 equals to 0. And which implies that p plus q equals to minus 5. I can call this equation 1. Also, x minus 3 is also a factor, which means x minus 3 equals to 0, then x equals to 3. That means f of 3 will also be p into 3 raised to power 3. Anywhere I see x, I will replace with 3 this time around, plus q into 3 squared plus 11 into 3 minus 6. So what's 3 raised to power 3? That's 27. So this one becomes 27p plus 3 squared, 9. 9 times q, 9q. This one, 11 times 3, that is 33 minus 6 equals to 0. So I will have 27p plus 9q. 33 minus 6, that will definitely give me plus 27 equals to 0. Then I'll have 27p plus 9q equals to minus 27. 9 can divide through. Divide this one by 9, I will have 3p. Divide this one by 9, I will have my q. Divide this one by 9, I will have my minus 3. So I call this equation 2. Let me now combine the two equations. P plus q equals to minus 5. Then 3p plus q equals to minus 3. So that's what I'm having. So I've combined the two equations now. So now, in order to eliminate this q constant, whose coefficients are the same, let me just subtract. So if I subtract, p minus 3p, that's minus 2p. Q minus q, 0. Then I have minus 5 minus 3. That's minus 5 plus 3. That's minus 2. Then let me divide both sides by minus 2. Minus 2p divided by minus 2. Minus 2 divided by minus 2. So this one becomes 1. And my p equals to 1. Then if my p equals to 1, then I can always use equation 1 to get my q. From equation 1, I know that p plus q equals to minus 5. And when my p is now 1 plus q equals to minus 5. Then my q will now be minus 5 minus 1. Then my q equals to what? Minus 6. That means my p is 1 and my q is minus 6. So I go to my options. Now, my p is 1 and my q is minus 6. So if you go by the option, so the one that has b is p and q respectively. P is 1, then q is minus 6. So automatically, the correct option here will be B. Since my p is 1, then my q is minus 6. Now, the next question asks us to simplify x squared minus 1 into x cubed plus 2x squared minus x minus 2. So in this situation, we are only asked to simplify x squared minus 1 over x cubed plus 2x squared minus x minus 2. The upper one is a simpler expression compared to the denominator. So denominator is a polynomial of degree 3. So what we need to do is to break this, because I know that this one is only testing difference of two squares. So it's this one that I need to break now. So if I want to break this, let me break this x cubed plus 2x squared minus x minus 2. So let me test whether 1 will work here. 1 cube plus 2x 2 raised to power 2 into 1 squared minus 1 minus 2. So this one is 1 plus 2 minus 1 minus 2. It will work. So x equals to 1 is the solution of this. Then x minus 1 will definitely be what? A factor. Take note of that. The way I select my words, I said x equals to 1. When I test it here, it gives me 0, making it that x equals to 1 is a solution. Why? By the time I transfer this one to the other side to now become x minus 1 is a factor of this denominator, that's the polynomial. So since I've known that it's a factor, I can now use long division method. By the time I use this one to divide this one, I will have a polynomial of degree 2, the one we call quadratic. So that is what? Then by solving quadratic equation or expression, this time an expression, by factorization, I will break it. So what I want to do here is to break this one down to 3, while I will break this one to 2, so that
Anyone that is similar, I can eliminate, and it makes my work easier, and it gives me a simplified fraction. That is the essence. So since I've gotten one, I now want you to use this one to divide this so that we get a quadratic, which I will simplify again to break it to 2. Look at the way I go about it. Since I have gotten x minus 1, I will now resolve to what? Long division. Put this polynomial inside. This divided by this x squared. Use this x squared to multiply these two terms. This time this x cubed. This time this minus x squared. Put a line like this, subtract. This minus this, it will cancel 0. This minus this, that will become this plus this, that's 3x squared. Bring this one down, x minus x. Use this one again to divide this. I will have 3x, that's plus 3x, plus 3x, that's what I'm going to get. Plus 3x multiplied by this again, that will be plus x squared. Plus 3x multiplied by minus 1, that becomes minus 3x. So I remove the line here and subtract. This minus this cancel out. Minus x minus 3, that will become minus x plus 3. And minus x minus 3x, that becomes minus x plus 3x. And minus x plus 3x is plus 2x. Then I bring the last one down, minus 2. This divided by this, that becomes plus 2. This multiplied by this, I have 2x plus 2x. This time this minus 2. Then I also introduce minus again. This one becomes